Hello, hello. Welcome to P5 to VVVV number 3. Yeah, thank you for watching again. This time again, we're gonna recreate one of the amazing coding train challenges in VVV by looking at the P5.js code and see how we can do it in V4. What we're going to do differently this time, because it's quite an extensive example, is I have already prepared everything, and I'm going to show you the things, the parts, and won't like code everything from zero, because otherwise that takes for ages, quite a bit. Yeah, we can see if that's better or not, but yeah, that makes everything a little bit shorter. So yeah, that example is the snake game. So you can basically control with the arrow keys the snake, and if you eat the food, the snake grows, and if you hit the walls or you hit yourself, it's not working with this amount of, but now if you hit the tail, it dies again, basically. So yeah, let's see how that might look in VVV. So we gonna create our own data type again, or to have the snake object. And in our case, we create a class because we want to change the class itself and not every time when we, for example, move or if a function gets executed, we don't want to create a new object of this. So we basically just want to manipulate this object. So we create a class, and inside, when we look at the structure of the P5 version, it basically creates a snake object here, and on setup the new snake is created, and then some snake functions get executed. Yeah, so yeah, let's look into the functionality of snake. So we go into our snake. So this is basically the whole patch, and we go into snake, and what we do first is, or what we would do first is we create the properties. So we create the x, the y, the x speed, y speed, total, tail, and scale property. And in our case, x is a float 32, y is a float 32, x speed float 32, y speed float 32, total is an integer. We just count like 0, 1, 2, 3 because the total elements. And the tail is a spread of vector 2 because we're going to store the x and y positions of the tail elements, and the scale is also going to be a float. So this is basically this part, and they are using integers here for the x and y speed. Well, we're going to use floats because why not? And the each functionality here takes a position vector, position vector 2, which is the position of the food. So if we see where we execute each, which is here, like if the snake eats, it passes the food position into that function. And in here we calculate the distance between the position of the head and the position of the food, and if the distance is smaller than 1, we count up total, and we return true. And if the distance is not smaller, we return false. So what we do here is we take the x and the y position, join them in a vector to join. So we have it in that format, and then we can calculate the distance between the foot position. And if the distance is smaller or equal to scale, we trigger the eating behavior, which in our case is we take the total and add +1 to it and store it back into total. Delete this. And we take a Boolean value, which we create with double right click, take a Boolean toggle, plug it into the if, and we want to like return wrong or false if this is not, if the if region is not executed, and if it is executed, we want to return true. And this is how we get this behavior. The next function is the dir, which basically takes the x, or yeah, when we hit the keys, we basically pass some x and y values and set them to the xy speed. And that's what we do here. We take the x speed and y speed that we defined, and we create an input which then gets passed every time a key. So we change basically the input depending on what key we press here. And that's the same what we do. So what we do here is we take the keyboard, we check if the pressed key matches the key how we want to control, and if it matches, we call the direction function and set the x speed or the y speed. And this is how we use the inputs. So we basically, yeah, have this key match logic where we take the keyboard, check if it matches the key that we want to use, and then we set the x or the y speed. Yeah. So this is how this function gets called. And yeah, basically set for internally processes, we set the x and y speed. So the next function is the death function. And what we want here is for each tail element, we get the position, and we measure if the distance between the head and all the tail elements, so each tail element is smaller than 1, and if, then the snake bit itself or hit itself, and we reset it total to 0 and empty the tail. And this is how we do it here. In VVV, we take the tail, x and y position, and for each element of the tail, we input it into the splicer, so we get each element, each position of the element, and we measure the distance with a grouped vector 2. Basically, we join the x and y position in a vector 2 join and calculate the distance. And if the distance is smaller or equal to scale, that means that we hit a tail element. And what this returns for us is, like, if we have like 7 elements and 1 is true, we want to measure if the spread contains a true value, and if that is true, it just gives us a single true value from if one element in the whole spread returns true. We just want to check if one true element is contained in the spread, and then we trigger the if. What we do here, yeah, if d is smaller, this is, we set total to 0, and we empty the tail spread. So if that's true, we clear the spread and it's going to be empty. That is the death function. And now it gets a little bit more not just copying, because V4 works a little bit differently than P5. So in P5, we just can have an empty list and just can start adding elements to it or set positions to it. But in V4, we first need to create an element in the spread to set something for it. So we have to like prepare a little bit different logic, because we have to, here first we take in the update, we have to check if the spread contains, or if the tail contains an element, and if not, we first have to add an element to be able to set the position later. So you basically can't just like create an empty vector, or create a vector in an empty spread. You first need an entry in the spread to set a position. So what we do is, yeah, if there's no element in the tail, to check it, we count it, and if it's smaller than 1, we execute the if, where we add one element in the spread, and we just set the current head position as the item. And if it's bigger than 0, so if there's an element in there, we execute the shift function, which is basically this behavior. And what that does is that it moves each tail segment forward by 1 position in the list. So the tail element 0 becomes the tail element 1, and tail element 1 becomes tail element 2, so they shift their positions. So we get this following behavior. And this is how that basically created, by shifting. And V4 has a use, or VVL.add-ons, which is a package which we can install by going to manage NuGets, and there is a vl.nuget.org and vl.add-ons. That's a really useful extension package for a lot of functionality, and you can install it by copying this, type it in your terminal, and then hit enter. I already did that. And this gives you the shift node, and that basically shifts all the element in the spread 1 position back. So yeah, it shifts the element at the 0 position back to the 1 position, the element on the 1 position to the 2nd position. And because we want to have that in, we need the shift takes the value from 0 to 1, the phase, all bigger, but we want to kind of know like how much one step is, and that depends on the length of tail. So what we do is we take tail, we count it, and then we divide 1 by the count. So we would have, like, if we have 4 elements, one step is 0.25. If we have 3 elements, one step is 0.3333. And yeah, we calculate this here. So it's adaptive to depending on the length of the tail, and set that as a phase, so it shifts depending on it. So this creates basically the shifting behavior. And the next is this if this total equals, so if it's bigger than 1, if the total amount of eaten is bigger than 1, we want to add a new element at the last position in the array. And how we do that is we take the total, we measure we measure if it's bigger equals 1, and then we take the tail and the total to check if total, or if the tail is smaller than the total. This is kind of like making sure that we're not getting outside of the length of the spread. And if that's true, we add an element with the current head position. And then we want to set it at the last position in the slice, which we do with a set slice of type spread. And we basically take total again and set it as the index, subtract -1, and then we save it back into tail. So we have this behavior. And now we want to set the x and y position by adding the y speed, which gets multiplied with scale. So take this, we take the x, take the y speed, and we take scale, and we basically, first multiply scale with x speed, then add it to the x, and they take here a different, they constrain it here with the constraint function, and we basically use a clamp and clamp it to the minimum width of our screen and save it back into x, and we do the same with y speed and y, and clamp it to the height of our screen and save it back to y. Yeah, this is already the update function, and what now is basically missing is the show. So what we do is we check if total is bigger than 0. So if there's a tail, we show the tail rectangle, because if there's no tail, we don't need to show this rectangle. But if the snake has a tail, we want to show it. So we take the tail, plug it into the if, and then for each tail element, or spread element, vector2, we show a rectangle and set the vector2 as a position and create a size for the rectangle from the scale value. We group it in a group spectral, and then we group it because we also want to show the head. So what we have here is the rectangle for the head, which gets shown here as well. So you see they do for each loop, and for each they do a for loop, and for each element in tail they create a rectangle XY position scale and then show the head as well. And that's what we do. Also, we here just show just the tail element as white and the head as yellow, just to distinguish it, and why not? That should be everything of the snake object. And if we go inside here, we see that we have basically the function setup behavior where we create the snake. We define a X and Y start position on create. So we right clicked on this, set it, assign, and create. So this gets executed in the beginning. We set a scale value here, and everything else is left 0. We store into a snake object. So this is basically what happens here. We have a snake object. Frame rate gets defined as 10 frames per second. And then they have a pick location function, which is basically dividing the green width and height by the scale, set as columns and rows, and then set the position of the food as a random columns and random rows, and then they multiply it by the scale again. So it is on a grid, the food lies on a grid. And this pick location gets executed when the snake eats food. So in the draw, which is kind of like the update function here, is they draw a background, they check if the snake eats food, then the new location for the food gets set, and it checks for the death. It checks update and show, and shows the rectangle for the food. And we also created a pick location function here by setting the positive width, range, and height. We negate it with a negate minus, and then we create a random position and output it. So how you create an operation is you right click, name it my operation, and then double click it, and then you can have some logic in here, which you even can have inputs and outputs. And what this does is you basically can use it here in your logic. And we use it, I create an operation because we have the functionality here and we have it there, so I don't need to create this multiple times. So yeah, on start we also create a random position for the food, store it in a random position. So we have it in the beginning here, and what we do is the key pressed here, they use the arrow keys and we use the W ASD keys, and if they are hit, we check if they're down, and if it's true, we change the X speed, which creates the movement which stores the X and Y speed in the snake object. We do this for all 4 keys to create the left, right, up and down behavior, and then we check for each. by plugging in the food position. This is what happens here. And because in eat we return true or false, this then allows us to execute pick location or not. So the random position for the food gets either changed or not and stored back into random position. And this that we then show just the food, which happens here. And after eat, we check for the death. So we check if the tail or if the head hits the tail. We execute update and we show it at the end, and then we store the snake back. And we then group it with the rectangle because we are in Skia. We group it together and show it in a renderer. And if we see that here, let me get that. Oh yeah, that's really slow. So I think the problem here is that, yeah, one direction. Where are we? This is direction show. I think the update is whoop, we have to go down. Let's see. That seems to fix it. Okay. So we basically, wait, where is it gone? Ah, it's here. So we are constrain it to the top and the bottom. But because our screen is now, yeah, that needs to be done kind of like fixed. So define the width and the height of the screen. Yeah, this fits. And yeah, we constrain it. And if we now eat a snake, eat a food, we add the element. And we have a fun game. I didn't do, in this case, I didn't do the column and rows thing. That would make it definitely a bit more pretty. There's a task for you. You also have to do your own. And yeah, you also could check actually re-trigger random, because you saw before that there could be an occasion where the random position is the same with the tail of the snake. But yeah, this is the basic functionality, and as usual I like to also make it a little bit more, yeah, why not using VVV to create a different visual aspect. So you kind of like can go into Stride and use that. So maybe you just you basically run this in the background. Or we could, yeah, you could try to use the keyboard inside this texture window, which I don't know which will work. But what you can do is basically you run this in the background, the interaction logic, and then you create a fun effects to make it maybe a bit more difficult to play. So you could like create really like make it quite blurry. And yeah, make it a bit more difficult. Yeah, that if you want to see that, that's really hard. Wait, let's. Wow. Yeah, that wasn't as intended. But yeah, now we see that we can also completely different. Could obviously, yeah, add a simple displays, filter, maybe take a different texture as a source. We don't need this, that's okay. Then you set a like bigger displays, maybe you make this a bit, whoa. Yeah, that's already, ooh, yeah, that's fun. So you could actually create a more organic ghosty game, ghosty toasty game. Let me see. Obviously that needs a really fun, doesn't need much, but so we could take feedback loop, plug this in there, we plug the feedback in there, then we create the loop, and then the feedback needs that back. Let's see how that does that look. Okay. Yeah, so you could like, yeah, create a fun trail effect, which just obviously makes it really quite too difficult probably, but why not? Create a like mod of a fun game, and if that's also, you know, the stopwatch in there, toggle it, enable it, and now that should kind of like, yeah, it moves. Obviously the scale of it all makes it also, you make a, makes the noise. Yeah, this can create a lot of fun effects. I can work on this for hours, so I guess I leave it now. But yeah, this time it was a bit different. We just worked side by side by already pre-made ones. Maybe somebody interested can tell me if that's good or bad. Yeah, thank you. And if somebody's interested in the patch, let me know. I can send it. But it's always better to patch it yourself to understand it. That's why I do it here, and that's why it's also not perfect, because I'm also try to explain it to myself and other people, and hope everybody's winning and learning something. All right, have a great day. Thank you for watching, and bye bye.